Hello.
Hello, everyone. Can you guys hear me?
Yes, sir.
All right. Okay, so welcome to ITS 454, 6 o'clock. This is our last week of content, as you know, right? Next week, you have your presentations. So hopefully everyone's looking forward to that. So that's basically the plan. Today I'm going to do the last lecture, just wrap up some of the topics, and then sometime I'm going to give you some reminders, and then some time for questions. And then on Thursday it'll just be an open lab. So I'll be there, and we can talk about anything if you want to ask any questions. But it's really it'll be just like if we had a lab in the classroom. It's just an open lab. Remember, there's no lab assignment because I'm giving you that time basically to work on your term project, right? And then so a week from today, so exactly 1 week from today, on Tuesday from 6 to 8, from 6 to 7:40, you guys will do your presentations. Okay, so don't forget, you'll present project A and project B. There's no real schedule, so it's not like I need you to present A or B. You can present both in a sequence, or you can present one on Tuesday, one on Thursday. It is up to you. But remember, there's two projects. Project A, I think, was the RCM, and then we went over that. There's a video on that, and then Project B is just, I think most of you have decided to just do the second part of the lab, of the VPN lab, which was to apply some type of a cryptography. So as you know, at the end of the day, VPN is really two ideas: creating the tunneling through routing, and that was the last homework that you guys had. And now that you've completed that, everyone is just focusing on the encryption, right? And so today I'll go over some of that, just wrap up really some loose ends. So as you know, and I've said many times, the encryption part of this is done through a protocol called TLS, which I discussed last week. But really, what the algorithm is doing, behind, or not the algorithm, the protocol TLS is doing behind the scenes is it's really just using SSL. So it's using SSL, secure socket layer, and this is something that we covered in 350 quite extensively. This took 10 weeks or so. So really today, as time permits, I will do maybe a little bit of a review just to give you some ideas, but that is all something that you guys are aware of. Okay, so again, I remind you, presentations are next Tuesday from 6 to 7:40, and also I don't think we'll be able to, given now that we have even more issues with technology and everything, we'll probably need both Tuesday and Thursday to finish out the presentations, Project A and Project B. Okay, so please don't forget that. Also, I want to give you the date for the final exam. So I think that's important. So the final exam, if you go to PNW final exam schedule, right? Our final exam. So our final exam should be for spring. This is spring 2020. So we meet on Tuesday at 6 p.m. And therefore, your exam is Tuesday from 7:15 to 9:15 p.m. So it'll be a written exam. We can't do the practical exam that I usually do in this class, unfortunately. So it'll be a written exam from 7:15 to 9:15 Tuesday, and that date is going to be May 5th. So May 5th. So you can look this up. You can look this up online, but it's going to be May 5th.
Did you say that was in the PM?
Sorry?
Did you say that was in the PM?
Yeah, this is definitely PM. So Tuesday, And that's going to be 7:15 to 9:15 p.m. I cannot change this, guys, because you know, one student might have a conflict with another exam, you know, so it's just, it has to be like this, whatever the university has given us. Okay, so that's your final exam. Final exam. Okay, very, very important. Please do not miss that. Also, your presentations. I want to make sure that's also clear. Presentations. Will be on April 28th and April 30th. And they will be from 6 p.m. to 7:40 p.m. Okay, and they will be through Zoom. So we're basically just going to do this. You know, you can, just like you've been logging in to Zoom and everything for the lectures and labs online, you'll do the same. And then you have to share your screens. Everyone can talk. So, you know, like a meeting of some kind. And don't forget that you need to present your project A and your project B. Okay, so the RCM and whatever this is, probably VPN crypto. Okay, so are there any questions? Don't forget that for all of this, you need to create a report. So I'm going to create drop boxes under the project folder. And you can submit your report with all your documents in there for both of these. Okay? So that's the plan and the schedule. So as you can see, we're in the, you know, we're pretty close to the end now. This week, you know, today, the last lecture, basically. Open lab on Thursday, just to kind of wrap up everything. And then next week, presentations. And then the following, your final exams. And we're done. You can enjoy your summers or your summer. All right. So before I get started with the current lecture for today, are there any questions?
Well, it's not necessarily a question, but more a concern. I was working on the second part of the VPN lab today, and now I can't get the VPN software to run when it was running just fine before. And I've rebooted the virtual machines, I rebooted my entire computer, and it still doesn't work, and I don't know what I'm doing wrong. And if I can't get that to work, then how am I supposed to have the VPN and the TLS working at the same time? Aren't they supposed to work at the same time?
Okay. All right. So TLS is the protocol that you're using to encrypt things, right? So you're building a VPN. In part, the very first part, the lab, what you did was you created the tunnel, you did all the routing, and you can send packets. Now what you have to do is, from your code, you have to send some kind of you have to achieve some kind of an encryption. That is your project. Okay, so if you, I have no idea how you corrupted your machine or what exactly it is that's not working. What is it that's not working? Does it give you an error when you compile things? Do the packet initiate? Are the ports bind in such a way that, what is it?
Well, I mean, I didn't change anything in the VPN .c files at all from the last time I ran it. So in theory, it shouldn't be an issue. But like, I don't get the message of got a packet from tunnel anymore when I did previously.
Okay, so you're telling me that you know, what we did last week. That's what's not working. It's not even the crypto part. It's just that part. It's not
The
working.
crypto part, I haven't even, like, I just took all day just to figure out how to even compile the TLS programs. It took a -LSSL flag at the end of the
Yeah, to add the library, the SSL library.
exactly. I figured I would make a public announcement about that because there's probably other students who are failing to compile the thing too. But anyway, yeah, I haven't even like gotten the TLS anything to run yet. I haven't gotten that far. I just finally got it to compile. But I was gonna set up the VPN stuff because that has to be set up first, right? Because if you don't have the thing you're trying to encrypt, which is a VPN tunnel, then you're not
That's a
encrypting
good question.
anything,
So
right?
actually,
So,
yeah, so that's a good question. So the way that you can think of your VPN tunnel, I'm going to erase this. The way that you can encrypt the way that you can think of this, really that code, the TLS code, is just to send, you know, you use it to send packets if you think about it. So there's two ways that you could approach this. One, if you think about it, right, you created all that tunnel. Now you did all of this, Kyle, last week, right? So you did all that tunneling and you then proved to yourself that you could send Telnet and what was the other thing? Ice Ping, which are two separate services, and you were just sending them through the tunnel. You were doing that. So one way of thinking about the VPN is that you could think of it as a separate program on the machines, and this would generate packets that then get routed through that VPN thing. So really it's like two separate things. Does that make sense?
well, I mean, that's fine. I mean, I figured the easiest would be to just run the VPN stuff on its own, get that up first, and then
That's
you
right.
try the TLS.
Yeah.
That's fine. I mean,
That's exactly what I just said. The other option is, obviously both of them are C code. This is C code, this is C code. You could always integrate them into one thing. It doesn't really matter how you do it. You know, either one is perfectly fine with me. At the end of the day, what I want you to understand is the concepts. So definitely, you should be able to establish your tunnel again, right? If you've done it once.
yeah, I know, and that's what's frustrating me.
Yeah,
is
I don't know.
because
I mean,
can't
I don't know
figure
what
out
to
why
tell
it's not
you,
working.
Kyle. It's something that you've done already, right? There's a video of it. So I don't know what happened to your VMs. I mean, I don't want to tell you to get new VMs, but
At this rate, I might need to.
It's sometimes the simplest solution is just to download the things again. If you understood everything, you remember there were literally just a rule, a gateway, and that was it. I mean, it wasn't that, and obviously the whole editor thing in VMware. But
Zana, you can't
what
send an entire virtual machine file.
Say that again?
That's
I'm sorry?
not going to work. It's way too.
Say that again.
Susanna put into the chat that she could try to send me her virtual machine files, and I'm like, how are you going to do that? Those are way too big to send in.
Well, you can just download them from the Seed Labs, right?
And I can just download it from the Seed Labs in any case.
They're
Oh,
right
I
there.
can use something else to send them to you though.
Don't worry about it. I can just get a fresh Seed virtual machine, fresh code from Seed Labs, and just, you know, do it all over again, I guess.
Yeah, I mean,
I just wanted to keep it from doing all that because I know that I can send them through something else.
yeah. So
Well,
aren't you working in a group anyway? So you know, you can Zoom and just use whoever has.
whoever has the thing that works.
That's right. So that's why it's a group project. There's no problem with that. As I said, there's two approaches to this, right? Two approaches. One approach is build a tunnel you already proved to yourself that you can run ping and telnet, right? Telnet is TCP.
Right, it is.
Code that you have is also sent as TCP, right? So you could try that TLS client, TLS server as separate things, and then just have them try to send data through the tunnel that you establish. If you think about it, actually those are built, that TLS client, for instance, this is client, let's say, is built to actually be able to talk to a real website like Google or something. You see that? So it really can do that mechanism, okay? And so what you're doing is you're leveraging that on top of the tunnel that you just built in the previous example, which is not inaccurate in the sense of how the ASA would do it, right? So the ASA would do something similar. The ASA would have all the routing rules in its own environment, right? It would open up a port, and then the packets that come in would be encrypted. They would have a specific header, you know. So it's not. It is, you know, it's a VPN. It's accurate. The other more difficult approach might be if you integrated both codes, like the TLS code with the, what was it, the VPN server code over here. But I'm not asking you to do that. It's up to you how you figure it out. Does that answer your question, Kyle? You have further questions? Besides,
Nothing that you could help me with. I'll just try getting a fresh machine and see.
yeah,
if
I
that
mean,
helps.
you know,
And if-
trying to fix why something corrupted. I mean, you know, you have to tell me a little bit more than that. So what is the problem? The program's not starting. What exactly is it?
I mean, it's not that the program won't start. It'll start. It just doesn't, like, the tunnel doesn't get set up correctly. And I'm pretty sure I put in the routing rules right.
Okay, so you think it's something that, like where you were last week, you had something, almost everything right, and you just don't. Well, if you want me to do that, we can do that either at the end of class today or at the end of, or all of Thursday, but we'll do pretty much the same thing we did. I mean, you have to bring up the 3 VMs, and I will ask you all the questions, because, you know, that's the only way that I can figure out where your problem is.
Okay.
Yeah, so that, I mean, we can do that. I have no problem with that. I mean, it's your lab on Thursday. And today, if we end a little early, but just bring up your VMs and share your screen. Make sense?
Yeah.
All right. So that's the plan then. Are there any other questions? No questions? All right. So let's see. I just want to Nathan, can you hear me? Nathan Solich, did you guys get my that email I sent you about the hidden Markov models? And if so, if you have any questions about it, or did that work for you guys? Nathan? All right, so he can't hear me. All right, anyway. So let's get started then. So today I have, as I said, these are the last slides. Okay, these are the last slides. And as you can see, it just says VPN design considerations. So we're going to talk about a few of the technologies now that you understand how to do, the tunneling and the routing and everything, and you're able to ping and telnet. And then now you understand also that on top of that is the cryptography. And so really, you can talk in a high level about VPN and some of these frameworks. Okay, so So this slide is called VPN design considerations. All right, so the basic foundation is identity concepts. And that's something that you have in that TLS code. As you know, you're authenticating things. You're authenticating, the host name, right? And you're authenticating the .pem files. So like the certificate authorities, okay? And you're authenticating a lot of things. So basically when you do VPN, you want to somehow authenticate things, okay? Now the most basic that we're all familiar with is application support for ID and password, right? And this is something that we're all familiar with. You have a username and a password. Even in your code, you have this opportunity to authenticate in the framework, okay? So, whether it is to a password in the code itself, or maybe it's a password that's being read from a file, or even authenticating from a remote service, right? And that's one of the things that we're going to look at today is something called AAA services, okay? Which is it's nothing more than a service that you have available. This is available from Active Directory, from the domain controller in Windows, right? So usually you would probably want to do this on Windows Server domain controller. Now, none of this, I'm not saying any of this has to be done for the project. These are just final concepts of how a VPN would then interact with other sources for authentication. The Windows Server domain controller. Okay, so of course about public key authentication. That's a topic from 350. This is a more secure, but also slower and costlier. Very, very reliable, built on cryptography, and also you need to manage your keys, right? So where you need a certificate and a certificate authority. Okay, and that's also a topic from 350, and it's also something that TLS is using. So all of these things are being used to authenticate username and password, username and password, right? We're using certificate authorities. We're using the actual host name, right? Because the host name needs to be in the certificate. So you need to authenticate for that. And there are other things that we can use for authentication as well. So for instance, there's a difference between the device versus user identity. Okay, so in the network, you usually have an identity for devices, a device identity, right? And that is its identity of a network entity, such as a MAC address. So for this, there's something called MAC locking, and it's a very typical network tool, okay, which basically allows you to, whenever you have like a switch or a port in an office, there's a port in there, a little port, and then that's connected to your computer. Well, when your computer connects to the internet, it first needs to go in here. It sends its MAC address into somewhere in the network, right? Very far away, probably. There's a database. Oops. There's a database with a list of MAC addresses. So MAC addresses. All right. So there's a somebody tells me why that happens. I wish I knew. All right. So there's a list of MAC addresses, and so usually what happens is the administrator, the system administrator of the network, will open up this. And when this machine sends the MAC address to the device, it'll decide whether or not it allows it into the network. So usually when they open, to all Macs, the Mac will be registered on this database, and then it'll be saved. And once it's saved in there, you can always connect that machine. You can always connect that machine to that port in the network. All right, and that's, it's called MAC locking, and it's an important mechanism used extensively. So for instance, in our labs in Powers 139, we don't really have MAC locking in some of those ports. You guys can connect your laptops, pretty much anything. But in other areas of the campus and other offices, MAC locking is enforced. Like my office, for instance, I can only connect certain computers to that MAC, and it's because they have been authorized, by the system administrators of the network. So that's usually referred to as device identity, and it's a very important service. It's one of the things that when if you had done your RCM on the school's network, it would have been one of the controls that everyone would have had and would have seen. So MAC locking, a very common service, and that is what is called device identity. So it can usually assert identity to a given device, but not the user of the device. So that basically means that, my computer's there, but, if I leave it logged in, with my user, then someone could use it. And, there's no, someone else is using it, basically. So that's why we also have user identity. And user identity, identifies the user, which is usually the ID and the password. Okay, so when you have a VPN setup, let me erase this. When you have a VPN setup, let's say we would have had the ASA, right, our device, connected to switch 1, switch 2, right, and then we had the router over here. And then switch 3. Here we have what would be a remote worker. Okay, and the remote worker is a person that would have, so in your previous lab last week, you guys saw a VPN server and a VPN client. So on the remote worker computer, the user would have a VPN client software. Okay? And so, just like that VPN client would do pretty much what you guys did. It would, take care of the routing, and it would take care of the tunnel, basically, and it would send information, across here all the way to the ASA, where the port number would be listening for VPN connections. So now the ASA would have been a VPN, okay? And so now, on the network in here, let's say that remote worker wants to access a specific FTP server that's on there. Well, it needs to be authenticated. Okay, and to authenticate it, there would have been a server over here. And that server is Windows. Usually the best one is Windows Server. Domain controller. Okay, so that domain controller would have 2 services enabled on it, which are service, I'm just going to write the service. So a service would be AAA, Radius, and also Active Directory for accounts. Active Directory. Okay, and so now the remote worker wants to authenticate. So first of all, there's going to be some type of a password, a little code between here and here. Right? There's going to be a code between there and there that they share. And so the VPN client would have that code. Okay, and they're going to exchange it in their communication. The ASA also then wants to authenticate that user. So the ASA, when it receives a message from remote worker here, it'll send out traffic to its own Radius server. So it basically sends the packet here to that Radius server. Okay, And the radius server then would authenticate that ASA. So it would say, oh, okay, you know, I know that this ASA is authorized. The ASA is authorized to make queries of me and to act, you know, as a control in the network. Then the ASA would send another packet. The ASA would send yet another packet. And this time it would still go to Windows Server, but now it would go to Active Directory. In Active Directory, you guys would then need to have a username and password. A user and password. All right, so let's say that, you know, the name of the VPN of the user, the remote worker is Henry Jones, right? So then Henry Jones is going to get a prompt from the ASA. What's your user and password? Okay, and so once it receives that, it's going to send that information, which is encrypted in the tunnel. The ASA forwards that information to the Windows server, right? And then the Windows server will give it to Active Directory, and it'll look to see if that user and password is there, and if that user and password belongs to the VPN group. And that's it. Does that make sense, guys? And so at that point, once all of that happens, the remote worker would be authorized. So think about it. We build a tunnel, then we encrypt the tunnel so that the data is secure, and then we still need to authenticate. And the way to authenticate is by, among other things, we could authenticate by a MAC address by sending that through the tunnel. We can authenticate the ASA itself as a controller of the network, as a network security device, and we can also authenticate by the username and password that belong to the appropriate group by using a domain controller and Active Directory. Okay, so are there any questions about anything that I just said? This is a question I'll probably ask on the exam. So if you have any questions, go ahead and ask. So really, notice here, I'm not really looking at like syntax. I'm not asking you about syntax. All of this would require not even one single, this wouldn't require one single command in the command line, because all of this usually, you know, as you have seen now with the VPN lab, doing routing rules, creating the tunnel, implementing the encryption by hand would not just be 1 or 3 commands. This would be a good number of commands on the ASA. And so that's why we usually just follow the VPN wizards, right? So we will follow a VPN wizard, and the VPN wizard allows us to do all the configuration very, very easily. So it's very straightforward. You just need a VPN software, remote worker, the VPN, and you need your domain controller, and you have to do the configuration on the Windows server as well. Because the Windows server, as I said, provides the services of identity, which is what that. Is this clear, guys?
This is the full aspect of it.
The full aspect of it? What do you mean?
Well, I mean, I don't know that we need any questions at this time, but I mean, there's a lot there.
Yeah, so I mean, this is the VPN identity, right? So all I'm talking about is how you identify, everything that needs to happen. So, as you've seen, the tunneling happens, then the encryption happens, but also the identity needs to happen. Usually when you do this with the VPN, you don't necessarily have to have, username and password. You could actually just make it very simple so that, it just authenticates here. But obviously if you have a large corporation and people are logging in, so, like you guys do, for instance, when you connect, I'm sure you've connected to the VPN, you have to type in some username and password. And so this is what's happening behind the scenes. So these 2 services in particular are important. You see that? All right, so I don't hear any questions, so I'm going to assume it's clear. So I'm going to continue here. All right, so that's identity. So identity technologies, which is kind of the central point now, this assumes, as I said, we already have the tunnel, we already have the crypto, and now we're just authenticating either the devices or people. So there is out there this. This is the service, remember. Now, if you have the ASA, it is certainly possible to do this. You have the Radius server as a separate device, and you could use Linux for instance, open Radius, and then you have the user and password authentication somewhere else. That's perfectly fine. However, Windows has created on Windows Server a way that you can actually you can have both services in the same machine. And that's very convenient because it really, here you're tying Radius plus Active Directory with username and password plus groups all into one thing. And so it makes it, somewhat more and more straightforward to do. Okay, so identity technology. So the first one, Radius or AAA, okay, provides authentication, authorization, and accounting. It is basically a service, whether on Windows or Linux, right? It is a service concerned with verifying the user and or device, identity. Okay, so it provides authentication there, and it's it's a type of username and password kind of thing. So for instance, you can also register the IPs, right? You can register the IPs that are allowed to query that Radius server or the subnet, for instance, and so you can provide additional restrictions, and that provides identity authentication. As far as the users, of course, you can use reusable passwords, right? So we all use reusable passwords. We now, all of us on campus, use these one-time passwords as well, right? So, I have mine in front of me. And then there's other things like you could have your own public key infrastructure, biometrics, that could be something, smart cards, etc. So anything that could provide authentication for you could be used in this medium. Okay. Now, Radius and TACAX, right? So these are basically focus on this authentication. So these are protocols with centralized authentication for a network. Okay. The easiest probably is just to use Radius on Windows Server. The next easier is probably Open Radius or Free Radius on Linux. And then this is Cisco's product, or it has been historically. So everyone can have their own implementation, but at the end of the day, they're very similar. And so the idea with these is, this is a server that provides a service in your network. It contains a database of usernames, passwords, and access rights. Okay, so you can control a lot of that stuff by, as I said, you can use a lot of things for identity. So when users authenticate to a device that uses Radius, such as, Windows Server, okay, the device sends login information to the central server, okay, and which itself would be Windows Server 2, and a response from the server determines whether the user is granted access or not. Okay, and so that's how you would test it. That's why this VPN lab makes such a big emphasis on doing the authentication, right? So the idea, because identity is an important concept when you're dealing with VPNs. So as I said, if you'd like to learn more, we're definitely, we're out of time this semester. I rarely use Free Radius. So this is one place where I think Windows does have the upper hand. So when it comes to like providing AAA Radius services and Active Directory username, password, definitely Windows Server, I think, is the way to go. And you can easily, and the great thing is you can easily integrate it into your network, so it's not even a big deal. So free radius open source for Linux would be this one though. So you could play with that if you'd like. And then, you know, the services basically provide username, passwords, access rights, and so on. Now, radius servers the name is interchangeable. Sometimes they're also called AAA servers because, you know, they record everything, they provide the authentication, the authorization. Radius is an open standard, and then TACAX, as I said, is Cisco. So a little bit more here. So just a definition. So authentication, the idea is who you are. Authorization is what you're allowed to do, right? So it's kind of put you. So for instance, with the VPN scenario, when you authenticate through that protocol, you belong to the VPN group. And so you will be you could be restricted. You know, they could send you information back, or even in the network, you might be, because you get a specific IP, right? So when you connect, you know, with the ASA, right, you get assigned that network. So if you remember when we did our lab, I think it was what, that 53 thing. So 192, 168, oops, .53. If you remember those tunnel network IDs, they were actually a type of this, right? A type of authorization, because it said, okay, only since you're using the tunnel, you're going to have this packet within the network, and they could put access lists in, you know, or routing rules in the network so that they would limit what you can access. You might be able to access a specific service, but not all services. All right, and then finally, the AAA does provide the accounting, which is, you know, just a log file, probably with syslog or something like that. It's sending information about what you're doing in the network, who connected, et cetera. That's, you know, very important, as you are aware. Okay, and then as far as location, as I said, you know, I think I have some pictures here, maybe in the future, but we'll talk about it in the next few slides. So where do you deploy a AAA server? So I already kind of told you, you know, because this is usually what we do in this class. You know, we put it in the domain controller, usually in switch 1, which means the internal network. So AAA server is master repository for all user identity credentials. Okay, and you know, can talk to a domain controller. And this assumes you're using like OpenRadius as a separate server, or literally they're both in the same server. So, you know, Windows Server would have AAA or Radius. I think it's called Radius, honestly. And also, you know, for username and password. So basically this says the two services can talk in the domain controller. They can talk, and you can add the users into the domain controller, and that's how you authenticate. And then this Active Directory just provides a little bit of a definition. Is what is called a directory service. It stores objects like users and computers and such things. And then, you know, a domain, I've said this many times, a domain controller, in this case, Windows Server. Windows Server is what the server running Active Directory is called. All right, so here's a little example, kind of what I drew, right? So you have a root AAA topology here. So you have your AAA system, right? That could be Windows Server itself. It could be OpenRadius or some other Cisco device, right? And then you have some client over here, like the remote worker in our scenario. And then that client tries to authenticate to all these devices, right? So for instance, you know, here, the VPN over there, the firewall, of course, and so on. So in our case, the ASA would have been, or is still, a VPN that connects to this guy. So our would go like that, right? And that's the process basically. That's just a topology. Usually I would recommend, you want your domain controller, on the inside network, right? So that people can't access it, and then it's really there. But this is how you can access it from the outside remotely. So even from here, from your homes, right? Whenever you want to connect to the VPN, you establish the tunnel, you secure the tunnel, then it's going to ask you for your username and password. That reaches the firewall VPN, and from there it is directed to the domain controller. It authenticates you, and then you're in. And it authorizes you, which means you get a specific IP for the VPN network, and then now you're kind of restricted within that, whatever that VPN network means. Are there any questions? Is all of this making sense? I know it's pretty simple actually, so I think, but it's certainly an important concept. Notice how a lot of machines, not just the firewall, right, but a lot of machines here would rely on AAA to authenticate them in the network. Okay. All right, seems like no questions. Now, this is more the topology where we would have, like I said, like a domain controller that has both passwords and AAA. So you can see it's the same idea. The client, where's the firewall? So the client goes through the firewall over here, or the VPN over here, right? And then it communicates first to the AAA, but then the AAA can query other things, right? So root user repository. So this is like Active Directory. So this graph just thinks of these two services as separate, but as I said many times, they can be in the same device. Okay, also this one would be the one-time password system. So we all have this, what is it called? Our one-time password, what is that called? Boiler tag or something, boiler key?
Yes, boiler key.
Yeah, boiler key, right? Yeah, so boiler key, right? So, that's the same thing. You're authenticating now. You authenticate to your username and password. They might have a boiler key server, and it's authenticating to that as well. Okay. All right. So the identity-aware firewall, it uses, let's say a radius to authenticate and do all of that with respect to the firewall. And as I've said, for passing through the firewall for VPN, etc. All right, so now that we've talked about the identity, let's just, kind of wrap up VPN here. Pretty much, this is kind of like a last summary of it. So VPN means to establish a private network over any other network. Right? Usually traverses the internet. The other network is deemed insecure. So that's the key thing. So in your example, that net was card or link or whatever, that was insecure. So, so because of this, you need to provide a better means of security, and that's why you use cryptography. So think about everything that goes into this, right? So cryptography, SSL, TLS, which is the protocol of SSL, but also identity. And that identity, think about everything that it includes, right? It includes your user and password. It can include the one-time password, right? It could even include a MAC or some physical IP or you know, whatever. So a lot goes into into the authentication or the security. Let's put this under security. Okay, so that's the main idea. So we've talked about this, so I'm not going to repeat that. This is just an example of the encapsulation. I think we've talked about it quite a bit. So that should be pretty clear. So I really just want to mention two things about VPNs. And then, oh, before I get to that, so that for the ASA, I don't have those numbers right now, but I can tell you encryption, as you saw in 350, can affect performance. It's a very key thing. And a network device has to be fast, right? So if you're going through the VPN, you're encrypting everything, it has to be really fast. So you can see here, I have some stats here for the PIX, which is the older devices. It can send 170 megabits per second of clear text throughput, 11 megabits per def. So whatever that is, that has gone up. So that has gone up for sure. But what I'm trying to show you here is the difference. Do you see the difference? Between 170 megabits per second versus 11 megabits per second. What's faster of these two?
Pretty lousy processor.
I'm sorry, say that again?
Sounds like a pretty lousy processor.
It doesn't matter, but just think of the difference, right? And that's just the difference with encryption. So as you can see, the encryption does a very, it does affect performance, okay? So I haven't actually looked at what the ASA's performance is. It's probably better than this for sure, but that's something that you can look up on Google, and I'm sure, I think we had 5510s or something that can give you that statistic. All right, so now two things that I want to say about VPN is kind of classifications of VPN, right? So we have what is called site-to-site VPN and remote-to-site VPN. Okay, so usually the simplest setup is this one. This is probably the setup that every one of you uses whenever you connect to VPN. Okay, so we'll just look at that. So also site-to-site, which is the one we're looking at here, also known as LAN to LAN or gateway to gateway. The idea is that you have two devices and they're connected. Okay, so the software is running on devices in the network, not on the computer of the workers themselves. Okay, so the advantages of this, all communications are encrypted and authenticated before they enter the other network. So you guys now, you've done all this, the routing thing, so you have I think a pretty good understanding now of how to forward things, so you can build the tunnels, you know how to direct the packets, and then so you can imagine how this is from across the internet. You have a company, maybe they have an ASA, right? And then over here you have another ASA, let's say, and then the ASA has the internal networks, right? So switch and the internal network switch over here. And so these two workers, this worker and this worker, are connected. Okay, so they're connected there. But what's really connected, when you do the configuration of the VPN tunnel, you're going to do it here. Okay, so you kind of have to synchronize these two. You have to synchronize this ASA with that ASA. So the two administrators, sysadmin 1, sysadmin 2, they have to talk and they have to agree on a certain set of parameters, right? You have to establish where the tunnel starts and ends, right? So you establish, you know, where the tunnel starts and ends, and then you also define the crypto parameters, some shared secret, some shared key that they have to establish. And that one they can exchange by phone or however they want to do it. Maybe it's the same administrator, goes from one office to another. But at the end of the day, this idea is that you have the Chicago office over here, Chicago office, and then over here you have the what is it? Miami office or some city. Okay, so you have two different cities, but they are literally connected through an encrypted tunnel. So in essence, they can communicate. You know, this computer can communicate with that computer. And that's the idea of a site-to-site VPN. Believe it or not, building something like this is not that complex with the wizards that you have nowadays in firewalls. So they make this very, very easy, actually. One of the things you'd have to do, obviously, you go here and you're gonna ping from here, right? So you're gonna ping from here, this one, and then from here, you're gonna ping that one, right? So first thing you wanna do is establish that you can communicate to that final destination. Once you can communicate to that final destination, you do all the configuration and you should be done. Are there any questions so far? All clear? That's great. All right, so let's keep going then. So here's an example of the site-to-site VPN, as you can see it. So you have site 1, site 2. Let's say this is your ASA or whatever. I'm just giving you, I'm trying to link it to the equipment we have. So there you have it. And then here you have your central site, and that's your ASA as well. All right, and so now, you know, you can establish these connections, right? You can establish a connection. Maybe all of these establish a connection to the central VPN server. They send their packets there. And from there, they can, you know, through that, they can communicate, okay? And so that's really the idea. So you do, that's site-to-site VPN. Usually when you're, it's simple enough when you're configuring it, you start the wizard and it'll say, would you like to configure a remote to site VPN or would you like to configure a site to site VPN? So of course, this assumes that you have the appropriate devices everywhere that will share, you know, the protocols that will, you know, that they have to agree that they're going to use DES and things like that, or AES or PKI, RSA, all of that. All right, so that's site-to-site VPN. Now, remote user VPN, or also remote to site, that's when the VPN, you know, there's a VPN server basically, like the ASA. There's the VPN server, but then, you know, in our scenario, this was the switch, this was the router, and then here, oh, switch 2, so switch 1. So remember, you are trying to always get access to FTP. FTP. And so there's only one device, and it's this one. It's only one device that's going to be a VPN server. And then from here, you have your remote worker, maybe a laptop, maybe your personal computer. And what you have running on here is you have a VPN client. You have a VPN client software. Okay, so you're going to have a VPN client software. You need to, so in your computer, you need to download that software. Then you use that, pretty much like the code that you have then you use the VPN client. Again, you have to put in some parameters in there that are the same parameters that you have here, right? And now you will be able, through that VPN client, to connect to the ASA. Okay, that is the remote to site VPN, and it's the one you use, you know, on your laptop. You know, we all have some kind of VPN client little program. Double click on it from Windows and connect, or something like that. So there are more types of VPNs. There's, you know, from browser VPNs, etc. We're not going to look at those. We're really just going to look at these two, site-to-site VPN and remote-to-site VPN. Okay. So here we have a little diagram for this. So we have, you know, the teleworker. Okay. And the teleworker has the VPN client on here. Or actually, maybe assume this person is at the airport, right? And he or she is working on the computer. And so they're going to fire up the laptop and open the VPN client. And then they just end up authenticated. And this is still some kind of a VPN device, like an ASA, and so on. So the whole process takes place. You've seen now how it works with the code. And that's pretty much it. Okay, so that's remote user to VPN. All right, so as you can see here, VPN, you know, provides encryption, confidentiality, provides integrity checking, ensure that no modifications were made to the data. So we've talked about that quite a bit. And then this is just an example scenario of remote site. You go through the internet, and then maybe you go through the router, and then the router directs you to a specific VPN gateway, or it could be like in our school, you know, in our lab environment, we just had one specific device that did everything for us, including the VPN authentication. All right, so that's pretty much it. This is just, you know, I had these slides just to kind of illustrate the configuration using the GUI. Right, so you got everyone in the lab pretty much was able to get to the ASA GUI. So at least I remember that everyone got to that. And I'm sure for a lot of you, I just showed you that you had it was a web-based device, you know, and you, it allowed you to do the configuration. So somewhere on here, I don't know if you can read this, but there it says wizards. I'm pretty sure that's what you had. And so from there, you know, you would go through the wizard, follow all the steps, do all the configuration, in a very straightforward way, and, you know, do the configuration of the device. Okay? So this concludes my slides VPN. Are there any questions about any of this? I know it's, you know, very simple stuff. I'm really just wrapping up the topics for the semester. Any questions? Questions? All right, so let's give me a sec here. All right, so the last thing, so I have some last slides here. And I kind of wanna finish up the topic, you know, the network security topics with kind of you know, at the end of the day, VPN does cryptography, right? And so I really wanted to just end the class with this, a short just reminder of cryptography in general. So are you guys seeing my cryptography slides, or are you still seeing the VPN slides?
VPN design considerations.
Okay. So then, okay. So now you're seeing my cryptography slides, correct?
Correct.
All right, so this is, we're gonna wrap up with this. All right, so this is the end of the slides. As I said, after that, I'll open it up for questions that you might have on the project or anything like that. And then, as I said, on Thursday, just open lab if you have, Kyle said he wants to go through the whole routing stuff again, so we can do that. Or any questions that you might have. Remember, you also have office hours. All right, so the final thing that we should talk about, we've talked about a lot of things in the course this semester. So I really just want to wrap it up, summary. So the course was network security. Okay, so one of the, we built our network. We used the ASA, had a router, right? And so you played around with a lot of that. Key things, defining gateways, routes, or routing rules. Let's call it routing rules, right? So you did a lot of that. Then you tried all the services. So that, we tried services like TCP, ICMP. Okay, so we went over that. We talked about, access control. Okay, and then from there, we started talking about a lot of you did your demo, so everyone did their demo. I'm glad I did that demo, actually, on week 3. So everyone did those demos, and then we went over the labs, and as you might remember, we saw very important topics like sniffing, and then the all-important topic of spoofing, which is the central concept in network security, right? Which is creating spoof packets. So any packet that's not an appropriate or authentic packet, where the identity or something is not who they pretend to be, then it's a spoof packet. That's by definition. So that's kind of the definition of a network attack. Okay, and so sniffing translates more into, yes, somebody could sniff your network and try to steal your confidentiality, but it mainly translated into devices that allow us to grab packets and look at them, right? That has been a very constant topic. So in network security, just like I gave you that idea that a marine biologist studies fish or the sea, network security, we study the network and in the network, what you have is the packets moving through. All right, then we explored the labs, attacks, TCP IP attacks. Oops. TCP attacks. Okay, on the physical network over here, we explored NAT, network address translation, so don't forget about that. All right, and it's a type of security, and it's a type of security and a type of access control. Okay, so we covered NAT, we covered static IPs, all of that. Rules, access control lists, and objects. Okay, and as we started to go through the labs, TCP IP attacks, so we covered several. So don't forget, I may ask questions about a lot of this. So we looked at ARP, right? Which had to do with MAC addresses. All of these were spoofing related. We looked at denial of service attacks, DOS attacks. Trying to remember the labs. I think we did something on TCP resets. We did obviously the session hijacking. And there were several types of that. And you saw is basically, now for that to happen, remember, it has to be a telnet. And even if you do it with telnet, remember that you still have to guess the sequence numbers and ACK numbers. And those were pseudo-random numbers that would be very, very difficult to guess because first of all, they were large. And so not easy with a dictionary attack, especially when those change in like a second, it'll be a different number. Right, so we went over that. Then after that, I think we did intrusion detection systems. All right, so in that case, we looked at snort. And in particular, we talked about how snort is different, or intrusion detection systems are different from firewalls, right? And so that took us to firewalls, of course. And snort, we just looked at rules again, rules and packets. And then we have firewalls here. And in firewalls, well, we've talked about the ASA. We talked about, what was it? We did a proxy firewall, which is an application layer firewall. And we also looked at firewall evasion by again creating tunnels, firewall evasion. Okay, all right, and then finally we looked at anomaly detection. So don't forget about that topic. And anomaly detection is also in the same category as IDS firewall, but the anomaly detection systems would focus mainly on zero-day attacks, right? So when you don't have signatures of an attack, this is where, if you don't have a signature of an attack, you still need to have some way of addressing it. So we went over anomaly detection. At this point, you start to get into like a really research type area of intrusion detection. There's a company, and then of course from here, it would have to be like AI. This topic we did not cover in the class, but it would have to be like an AI type of IDS. And those actually exist. I want to show you, for those of you that that might have curiosity about this type of tools, there's a company out there called Blue Vector. So let me, I want to keep saying. So there's a company out there called Blue Vector. And this might be the future of all of this. Who knows? Yeah, I need to share it. Can you guys see my the Blue Vector website?
Yep.
Yeah, this company is actually very interesting. When I first met the people in this company, it was a division of Northrop Grumman. Then Northrop Grumman spun it as its own thing. And then they were Blue Vector, a firm for a while. Now you can see Blue Vector is a Comcast company. So don't be surprised, for those of you that have Comcast, if the technologies from that company start to make their way into, your own internet experience, right? So you can see it is now a Comcast company, and really this is the future. I mean, this is you know, you can see here, this is intrusion detection system, the next generation of intrusion detection systems. And they are based on, you know, AI, more intelligent, you know, smart, I guess, it would be the term. So smart systems for intrusion detection. So anyway, just something for you, you know, if you have an interest in looking at more how things are evolving in the future, this is certainly something to look at. So you can see, you know, get better answers, not more alerts. So it's just, it puts an emphasis on making things a little bit more intelligent, okay? Okay, all right, so anyway, I wanted to show that. So let's kind of wrap up. So let's go back to the slides here. All right, so as I was saying, so, you know, these are the final topics. And then the final topic, of course, you know, is, was VPN. And VPN just leveraged a lot of what we were doing, you know, everything else that was going on. And it had to do with the network, but in particular in securing the network with cryptography. Okay, and so that's really, you know, that's really what it is. So that's why I wanted to kind of end the course with just a little bit of cryptography here. Okay, and you know, we learned, how can I put this? We learned pretty much all the main concepts of cryptography in 350. So there's really nothing new, right, that I can give you. Even TLS, which, you know, I explained this, I'm pretty sure, last week. TLS is basically SSL. Can anyone tell me, because, you know, this will be a question on the exam, on the final exam, can anyone tell me what is the difference between TLS and SSL? No idea, really?
From my understanding, TLS is nothing more than SSL as a protocol instead of as a bad term, but an application.
Yeah, perfect. That's it. So yeah, I knew I had covered this. So exactly. So SSL is really, we learned with SSL, it's like we learned the algorithms, the methodologies, the techniques, the frameworks. And then here TLS is just a protocol that allows you to put everything together in a package. And what you're doing now in your project is you're really implementing the TLS code. So if you start reading through the code, you see that you're using SSL in there, you know, and basically the TLS protocol, and you're using the functions to achieve those things, right? So you create a communication, you authenticate, you set some parameters with the keys, the PKI keys, and then after that you just send and read data. That's really all you do. Okay, and so exactly what Daniel said is exactly right. It's nothing more than a protocol that uses SSL. Okay, so what I'm gonna do now is really just to kind of wrap up with cryptography, I'm just gonna ask you a series of questions. So I'm really just gonna take it like that. As you can see, these are the slides from 350, okay? And all I wanna do is make sure that there are no questions on these topics. So look at this slide. So I'm really just going to look at this slide here. Public key certificate. You're using this, of course, for your for this final project, right? So can anyone explain to me what's going on here with the public key certificate? And you can read through it, just, you know, if somebody wants to just kind of finish out the semester, just summarizing these topics. So what's going on? What is logically going on here? And this actually is very central. You know, I selected this slide in particular because I know you know all these concepts, right? All these, you can think of them as primitives or principles. You know all of them, which are put together to build this. But this is central to what you're doing in your project. So who can describe what's going on here? Okay. No one? Really? Can you guys see this? Is this too small or something? I'm gonna pick some names. Let's see.
Yeah, so like you're creating
Yeah.
a hash of the public key,
Mm-hmm.
Bob's public key, and then the CA is kind of saying that it is Bob's public key, like certifying that it's his key,
Mm-hmm.
and then you decrypt that, like whoever receives it decrypts it, and
Yes? No, yeah. Good answer, Susanna. Thank you. I appreciate it. So this is exactly what happens, right? When you have a public key, right? So you need to have the name. Oops. You need to have the name. Please. Hold on. Okay, so go back to it again. Okay, here. So, okay, there we go. So you have the name of the person or the name of the company. This is very important, okay? This has to always match. You know, if I say, Netflix. So I say Netflix. That is the name of that company. So in that certificate, I want to write my name. And in particular, you know, I'm going to say like www.netflix.com. No one else can have that name and that public key in the same place. Do you see that? Because my certificate authority will sign that. And so what's going to happen is when you decrypt it and you check that name will be Netflix. And so you're basically with that confirming the identity of that company. So if you think about it, the certificate includes the name. It also includes the public key of Netflix, right? And also some additional information. For instance, information about the certificate authority. Now that data, all of this can be clear text, right? So clear text, because remember that the public key is, well, public, right? And so that's not a problem. The key thing is you want to make sure that nobody changes that public key and nobody changes that name. And so, you know, that's a fundamental concept. And so that's going to be your unsigned certificate, which contains those parameters. You're going to run it through a hashing algorithm. So you run it through a hashing algorithm, and that generates a hash. Why do we create a hash of it? What's the value of a hash?
authentication,
Sorry?
integrity.
Integrity, right? So we make sure that nobody tampered. So we're making sure that nobody said, you know, ooh, I'm going to say Netflix1.com, and then, you know, I'm going to redirect them to my page. Or nobody changed the public key either, right? So that's what the hash is for. And so we complete that part. And then what happens here? The certificate authority is going to encrypt that hash, not the whole thing, just the hash. Why does that happen? Why does the certificate authority encrypt the hash?
So when the end user decrypts it with their public key, that is the
Who's public key? Who's public key?
certificate authority's public key,
Okay.
they can then know that it's signed by the certificate authority and that it is Bob's actual hash.
Perfect, perfect, exactly. The certificate authority here is signing it, right, with their private key. And only everyone in every browser and when you guys are doing this VPN lab, you could set up a folder with the certificate authority's public key, right? And so you can check something signed by the private key of the certificate authority can only be, or encrypted, can only be decrypted with its public key. And so that, even though that does not, everyone can do that, so it doesn't achieve confidentiality, it does provide authentication. Very good. Okay, so we perform the authentication there. So now we attach basically the signed hash to the public key. So you're sending that in clear text, Bob's ID, the public key, and the hash with the signed by the certificate authority. Then when it's received on the other side, then you take, let's say the person that receives it here on this side, takes that same clear text, Bob ID, public, the public key, the certificate authority, runs it through the same hashing algorithm and calculates once again this hash and that hash, right? So you're going to get that same hash if no one has tampered with the data. So now you have the hash of the data, and the last component is that, as Daniel said, you take what's attached in the certificate, which is the signed hash, you decrypt it with the CA's public key, it decrypts correctly, you get the hash, and now you compare these two. If they match, then you accept the key. And in this whole process, we have provided integrity and authentication, which is really what we need for the exchange of the public key. From here on, now we can use the public key to do the confidentiality part. And from there, that basically allows us to do the whole encrypted tunnel. All right, and I think, if you understand this one slide from 350, there's no need for, for me to go through all of this, because all of this is just the primitives for that. Okay, however, I have put this here just for you guys to kind of refresh your memory if you feel that some of these don't really, you don't remember them maybe, or you're just a little bit confused by them. All right, but at the end of the day, that's what's happening. So you can always just reference back to that slide. All right, so that's it. So that's that's all the contents for the semester that we had. So, I'm glad we got to cover everything, really. Unfortunately, we missed a little bit of playing with our physical hardware, which was fun, I'm sure, for you guys. But it is what it is. So, so that's it as far as the lecture for today. And this is really, I wanted to do a summary of everything, remind you of the topics you might expect for the exam. So all that's left now is, if you've already submitted your lab, the first, creating the tunnel from the VPN lab and everything else, then really all you have left is three things. You have Project A, Project B. Presentations are next week. And then also the final exam. So at this point, I'm going to finish the lecture of new content, and I'm just going to open it up for questions, open up the floor to questions if you have any. And then otherwise, we will meet on Thursday at 6, and it's just an open lab, really. So I'm not planning on giving any lecture. It's really just, like Kyle said, he wanted help, or if anyone else wants help, but you have to share your screen, okay? So I can, we can figure out. Otherwise, I will also have office hours on Thursday or by appointment. Okay, so that's pretty much it. And now if you have any questions, please go ahead. And then Nathan, are you there, Nathan Solich? Okay.
Professor. You're muted.
Yes.
Okay. Can I ask you some questions about what is it, ITS 530?
Give me a sec. Let me. I don't want to make this video just. So let me just close this so I generate the video and then I'll connect back again.
Oh, okay. All right. That'll work.
So yeah, that'll. Let me do that.